Hello, welcome back to my channel. My name is Rahul Singh, and you are again welcome to Chemistry with Rahul. So, till date, we have studied up to like galvanic cell we have seen, and also we have seen the electrolytic cell. The difference we have seen the electrodes and what exactly charge is present on electrode. We in last lecture we have differentiated both the electrodes. So in electrolytic cell, we know that it is electrical energy is converted to chemical reaction. That is a hypothetical term. In that particular case, we have to apply energy from the outside. Due to that delta G, that is a Gibbs free energy change is positive in that case. Okay. And at anode, there is a positive charge, and at cathode, it is negative. While in galvanic cell, anode is negative charge and cathode is positive. The difference we have already seen, and I have given you one trick that is basically related to that particular how to differentiate that between like what is cathode and what is anode. We are familiar with that. That is CR and OU. That OU sound we have to remember. That is CR is always to the owling sound. So this we have to remember. Cathode does the reduction, and at anode oxidation is possible. So accordingly we have to cross verify that particular thing. So in previous lecture we have drawn that two cells were there. Okay, we have drawn two cells, and with the help of electrochemical series we can do that particular, we can understand that particular thing. So in that two particular cells we have taken, in one cell we have taken zinc sulfate. Okay, zinc sulfate solution we have taken over here. This is our ZnSO4, and the electrode we have taken of it was of zinc only. Okay, this was from the zinc itself. And in another solution we have taken, that is a copper sulfate solution. I'm just drawing it to understand. Copper sulfate is always blue in color, copper sulfate, and the electrode was also from the copper itself. So we have taken this particular thing, and we have just connected. And now we are going to place a voltmeter. We can place anything. We are placing a voltmeter to measure whether the electric current is flowing or not, because the flow of electron, the basic potential difference is exactly opposite. Flow of electron was like this, and potential difference was opposite to that particular thing. So due to this, we have seen that in ZnSO4, here we were getting like from here zinc plus 2 was released in the solution, and here copper plus 2 was like it was getting like in here this copper plus 2 was there, it was taking 2 electron, it was getting deposited. Cu plus 2 was getting deposited on this particular electrode over here. So up till here we have seen, and at initially this particular reaction was last for 2 to 3 minutes. This we have seen 2 to 3 minutes. This was done in the backyard of the house. It was for the scientist who has done that particular thing. Now here we can see that at earlier, when no reaction was there, the concentration of Zn, we can see that the concentration of Zn plus 2 will be equal to sulfate at initial position. And for this one also, the concentration of Cu plus 2 was also equal to SO4 plus, sorry, minus 2. This was also SO4 minus 2. Yes. So Zn plus 2 and SO4 plus, this was also minus. This was a minus. Okay. SO4 2 minus was there. So once we have started, like here now the reaction has been stopped. We wanted to investigate what was the reason why the reaction has been stopped, that we have to find out. So when reaction has started, so Zn plus 2 was immediately it was sent to the solution. So here we were getting a negative charge over here. The point over here we were getting a negative charge. Yes, all negative charge were here, and positive charge was sent to into the in this particular solution, and here we were getting a plus charge over here. Yes, because copper was getting deposited. So we can show this particular reaction. Like in case of zinc, we were getting zinc. Zinc was given out to the solution, and we were getting zinc +2 and 2 electrons were deposited. So inside the solution, the concentration of Zn+2 was increasing. So we can denote this after this particular reaction has been started. Zn+2 was greater than SO4 2 minus, and in this case here we can see that after certain this copper Cu+2 was getting this 2 electron, and it was deposited on that particular electrode. This is our copper electrode and this is our zinc electrode. Yes, zinc we can write over here, zinc electrode. So due to this copper was Cu+2 was getting, like it was like Cu, then it was Cu+2 was decreased in the solution, and SO4 concentration was increasing in that particular solution. So from here we can see that plus charge in this particular solution was increasing, and negative charge in this solution was increasing. So if this Zn+2 will be like here, as plus charge was already there. So if this Zn+2 will be donated toward that particular solution, and electron will be given out. So this Zn+2 will try. Zn+2 will be more Zn+2 will be there, and it will try to capture one electron. The whatever electron will be delivered or loosed by that particular Zn+2, it will be gained by this Zn+2. So due to this, there was a no flow of electrons, and even if the electron overcomes that particular like positive attraction, electrostatic force of attraction, and tries to move towards the system over here. So when Zn electron reaches over here, this solution was already negative in nature. This was already negative nature. So negative repulsion will be there. So due to that, this particular reaction has been stopped. So this was the reason behind it. Like there was electrostatic force of attraction and repulsion. Both of the things were working together after certain time. So what exactly scientists has done? So scientists tried, like they have tried, like after to minimize this particular thing. What they did, they just again put that particular. So same solution, zinc sulfate I'm placing over here, and for this CuSO4, copper sulfate is over here. We are having 2 electrodes over here. Yes, like this. And there was a voltmeter, we can say, to see the reading. Okay, was placed over here. And this was our negative electrode. This was our positive electrode. This was made up of copper. This was made up of zinc. And the solution, it was made up of zinc sulfate. Yes, and this was of copper sulfate. So what exactly happened over here? So to continue to make this reaction continue, the scientist has invented one thing, and that particular thing was nothing but an inverted U-tube that is called as a salt bridge. That was called as what? Salt bridge. We will be studying about that particular thing. So what exactly the salt bridge was, we will be seeing about that. So salt bridge was an inverted U-tube type of shape. Okay, this will be like this. This was there. U-tube was there. So in this particular U-tube, the particular here we got agar-agar solution. Agar-agar paste was inserted in that particular thing. So what exactly this tube is? first we will try to understand about this. So basically, this salt bridge, we will write about this particular green part over here. It is called as a salt bridge. This is very much important. Many students are confused about this one. What exactly a salt bridge? Basically, it is a in this particular salt bridge, the inert electrolyte is placed. Inert electrolyte is placed. So inert means it is not going to react with that particular solution. So the electrolytes are nothing but KCl. Okay, KCl will be there. Potassium nitrate will be there. Ammonium chloride will be there. Sodium nitrate will be there. These are the types of inert electrolyte that we have to fill in that particular U2. With the green color, I am showing that particular thing. So basically, salt bridge, it is a inverted, it is a inverted U2, inverted U2 in which inert electrolyte is placed with agar paste. Agar paste means it will be a gel type. So why we are keeping gel inside this? Because when we try, when it is inverted, so the solution, if it was a liquid, it will just flow inside that particular zinc sulfate and copper sulfate. So no reaction will be taken place. So the gel itself, it will stick to that particular area itself. And we just put a cotton over here. We just put a cotton over here. Okay, cotton will be there. So here we get a cotton. The cotton is placed over here. Cotton. So why we put a cotton over here? Because if cotton is there, the agar solution will be, it won't come outside of that particular gel tube, and the reaction will be carried out over there. So we are just trying to understand. We are putting a agar solution. I'm just showing it by like this. I'm just showing it like this. That is a agar solution. Okay, this is our agar solution. It is a gel type. So now we understood why we are putting a agar solution as a gel part, because when gel is kept inside that particular U2, it will stick to that particular area only. And when we give a particular cotton, so it will be keep a contact in between the solution and the paste itself, so that it can be continued in that particular format. So this is a gel in semi-liquid format, in a semi-liquid state. So we are having these examples over here. So suppose if we are taking a KCl, K is in a positive form and Cl it is in a minus form. Okay, two forms we are having. And as we have seen that this zinc sulfate, after a certain time, it has become positive and this particular form has become negative. So the chlorine from this particular state will slowly, it will try to come inside the solution, and this positive K plus will try to come to this particular solution. So they will try to maintain that particular charge flow to continuous flow of electron. Means K plus will be over here. It will try to come like here. It will make that sulfate solution will be there. So sulfate and SO4 and SO4 2 minus and K plus will make a balance in between the solution, and it will not affect this particular coming electrons. It will not create that particular electrostatic force of repulsion over here. Yes, and Cl will maintain that particular. So it is not going to react. It will stay inside the solution as it is a neutral inert. So it will stay as it is, and it will try to keep that particular flow of electron continuation. So this is a main use of a salt bridge. That's why we use a salt bridge over here. So this is now what exactly the working over here. So working we will see, that is a working of salt bridge. We will see now working of salt bridge, working of salt bridge. So what exactly the working? Actually, I have explained you the whole working. So here the main purpose of this one, it completes the circuit. It completes the circuit and maintains flow of electron that we actually require. Maintains flow of electron, and also we can say that basically here it maintains the electrical neutrality. It now what we said, it is not reacting with each other. It is just stayed in as a neutral part. Neutrally, it is staying inside the solution. It is not reacting. If it will react, it will form a that particular precipitate. So the reaction won't carried out. So it maintains the neutrality. It maintains the electrical neutrality. The electrical neutrality of electrolytic solution. And third one, that is very much important part now, as we have seen that here the positive charge is there. So here all the negative charge will be shifted, like all here Cl minus will be it will come toward this side, and positive charge, all the positive charge will try to come to this side. So right part of this will be completely filled with the positive charge, and the left part will be try to cover to the left side. So positive, negative. Here we are having positive, here also positive. Sorry, here we are having negative. This is as positive. This is negative. This is positive. So overall, we can see that junction barrier. It is called as a junction. Two junctions are there. First one is our main junction, and this one is another junction. So if this electron, this particular negative charge is not flowing properly, it is going to stop that particular electric current. So we just needed that particular thing. So this negative charge should be immediately drop towards the solution, as this negative charge is going to travel. So the speed must be there, because it must be more like mobility should be there in that particular electrolyte. So it maintains, like we can say that it reduces, it also reduces the junction barrier. So junction, if the flow of that particular electrolyte is slower, so it is again going to stop reaction. The reaction is going to stop again. So what we required over here, the flow of that particular the particular electrolyte should be maintained properly, so that it won't create that particular barrier over here. So it also reduces junction barrier over here. Junction barrier over here. Okay, so this is about this one. So this is main junction. So it is going to, this particular electric current will be, EMF will be maintained over here. So this is about the working of the salt bridge. And after this, we will be like properties, which are very much important. We will be moving towards the properties. That is how, what kind of electrolytes should be there. So next part that is very much that is important, that is properties of electrolyte filled in inverted U tube. Okay, inverted in inverted U tube. So as we have seen, it must be inert. If it is not inert, it is going to react and precipitate will be formed. Reaction is going to stop. So first point that is very much important, it must be inert. It must be inert. Okay, and do not react with the solution, and do not react with solution in half cells. So, and here we have one exception, that is we have to keep in mind. So if we use like with Ag electrode, with silver electrode, we should not use KCl. KCl means our inert electrolyte, because it is going to form Ag plus, it will react with Cl minus to form a AgCl. It is going to form a precipitate. Okay, so that we have to keep in mind, that we should not be doing, because with Ag we have to take not KCl, AgNO3 will be we can take. There are many examples we have seen. Sodium nitrate we can see. So second must be the mobility part, that is very much important. The mobility that positive and electron mobility in positive and negative ion of electrolyte filled in inverted U tube must be same, because mobility should be there. If they are not mobile, they are going to stop the reaction. So more like we can also use H plus, and more mobility will be there, is seen in H plus and OH minus ion. So this is all about the salt bridge, how salt bridge work, and it maintains like this. These are the properties which are very much important that we should remember. So till now here, this is the main part that we required. So after that, we will be moving toward the electrode potential. So, and how it is going to react. Like after certain time, zinc, which we have placed in ZnSO4, will be decreased and copper will be increased. So the active electrodes will be there. The solution part we are now talking about. So on that particular basis, we will be moving toward the electrode potential. So that after that, we will be moving towards the Nernst equation. That is very much important part of this chapter. So I hope up till here, you must be your all the things which we have discussed over here are clear to you. So keep on studying and all the best. Thank you very much. Bye-bye.